What's up, everyone? This is LeetCode 78 subsets. This is going to be our first introduction to the topic of backtracking, which is what the approach we're actually going to have to use to this problem. Okay. I'll touch on that in a little bit, but basically, this problem, right? We're just given an integer array nums of unique elements, and we have to return all the subsets, also known as the power set. And what are subsets? A subset of an array is a selection of elements of the array, but it also could possibly be a selection of no elements, right? So the empty array could be a subset. A solution set must not contain duplicate subsets. Return the solution in any order. So basically, we're given this array and we have to return all the possible kind of selections of elements of the array, right? So for example, we have this array 1, 2, 3, right? We can take the 1 and not take the 2 and the 3, right? We could take the 2, but not the 1 and the 3. We could take the 1 and the 2, but not the 3. We could take the 3. We could take the 2 and the 3, the 1 and the 3, right? So you can see these are all unique though, right? We don't have any duplicates. You kind of, I mean, just by looking at the output, you kind of understand what you have to do in this problem, at least conceptually, right? But implementing this is a little bit tricky because we have to use backtracking, okay? Now, I'm not going to go over backtracking too much because it's kind of its own separate thing that you have to learn on your own. I will explain the solution, obviously, but this is a bit of a tricky problem. I'll try and explain it as best I can, but we're going to have to use recursion, right, which is kind of how you do backtracking. And I'll try and explain our call stack and explain this problem as best I can. Okay, so we're going to need to do some recursion. So let's create a function called bt for backtracking, right? And then down here, let's just return this function. Okay. Or rather, let's just call it. And then what do we have to return exactly? We have to return some array, right, of all the subsets. So let's create that array. We'll just call it answer, and we'll return it down here, okay? And then we need to do some backtracking, and in this backtracking, we have to do something to add to this answer array, right? So this is kind of just like our skeleton so far. So we need to remember one thing, right, which is that the empty subset is a subset, right? So we need to keep that in mind. So, now in this backtracking function, what we're going to pass is we're going to pass some index and some array, right? Because we need to have an index because, as we go deeper and deeper into the recursion calls, right? Right, we might want to take this 1, you know, and move forward, and also take this 2 as well. But maybe we want to also backtrack and then skip this 2, but take this 3, so we have 1, 3, right? And so we need basically an index, and we need some array that basically maintains what the array is at a given call stack. And the reason why this problem is a little bit hard is because it's kind of hard to explain things in words. Because we have like a bunch of call stacks, right, as we're doing this recursion. So I'll try and explain stuff and kind of write it out in comments so you're not lost. And I hope it will make sense, okay? So initially we just have an I, which is our index, and this is our array, okay? So initially I is going to start 0 because we're going to start at the 0th index, right? And remember, we can have an empty array, okay? So initially, we just pass an empty array because we don't have anything, okay? So we kind of need like I guess we'll call this like a base case to break our recursion. Remember how recursion works, right? We always have a base case that will terminate the recursion, the recursive call, right? So our our base case is basically what? Well, when I is basically the length of nums, right? It means we're basically out of bounds, right? So in that case, let's just take answer and append array.copy and return. Okay, this is just our base case, okay? Basically, when I goes out of bounds, we're going to take whatever array is, put it into answer, and then return. Now, we need to do r.copy because this is technically an object. So if we append array into answer, but we change array, it'll actually change that within answer as well. So we need to make a copy, okay? Just because of how Python is with everything being an object. And kind of like a reference to an object. So that's our base case. Okay, and now down here is basically where we actually do the recursive calls, okay? So when we're at a specific index, we're gonna take we're gonna take the element that we're on and we're gonna append it to the array variable, okay? So we basically can take and then don't take. This is basically where we backtrack, okay? So when we're at a given index, we're gonna basically append whatever the element we're on to array, and then we're gonna move forward in a recursive call stack, okay? So we're gonna do I plus 1 with array. Now back here is basically where we want to backtrack. So remember how we backtrack is we basically want to take what we added, pop it, but move forward an index, right? So that's like why we want, sometimes like think of it like this, like in a call stack we'll go 1 2, right? But we also want to include 1 3. So how would we ever do that? Well, we would pop this from the array, not from this array, but we would also move forward index. So we still have this 1, but then we'll also cover this 3. So we'll get 1 2, but we'll also get 1 3, right? And so that's why backtracking is very important and useful for this problem. Okay. Now, I'll try and show this as best I can, because I know this is kind of a little bit confusing if this is your first time doing backtracking. So the way we would do this is right, you would start with an empty array, right? Because again, we're calling this function here with the index 0 and the empty array, right? So initially we start with an empty array, okay? This is kind of how the call stack would go, okay? So initially we have an empty array, then we go to a 1, right? Because we're at index 0, right? So this, we don't hit the base case yet. So we go here. So we're at index 0. So we add this 1 here, and then we recurse inwards. So basically we move forwards and call this function again with the index above that, I plus 1, right? So we add 1, right? And then we go here. So we go to the next index, which is 2. And then we go again, right? Now we add the 2 here. Okay, so we have 1 2. And then we go into BT I plus 1 again, right? So we go to the 3. So then we add the 3 to the array. Okay. And then we basically go recurse again, but now we're out of bounds, right? So we're out of bounds. We hit the base case basically, right? So what do? We add this R, right? The array R to answer, because we basically hit here, right? So now we had basically 1 2 3 into the answer. And this is actually an array within an array, so it's something like this technically. Okay. And so now what we would do is we would pop, we would go backwards, and now we would pop the 3, and we move, so we pop the 3, but we go up an index, and we're out of bounds again, so we add the 1 2. We add the 1 2 as well, right? Okay. Now we pop the 2 and we go forward, and guess what? Well, now we add the 3, so we have something like, in R we have something like this now. So okay, let me explain this. So we have this, right? We recurse forward, we move the I forward, the index forward, we're out of bounds. So we add this to the answer array, okay? Then we pop the 3. Now we're at this index 1, but we don't take the 3, but we move forward. Or sorry, when we pop the 3, we're at index, technically we're at index 0, 1, we're at index 2, but we remove the 3. So we move forward again, we're out of bounds in terms of the index. And so we add this array to answer, which we did, right? Now when we go here at line 19, we pop the 2 now again, because we were out of bounds, right? We just hit the base case. And so now instead of, we're at index 1 in that particular call stack, we go to index 2 now, and we add the 3, right? Now we recurse forward again, and now we're out of bounds again. So we add this 1 3. Okay, the reason this is hard to explain is because we have a bunch of call stacks happening, right? And we're basically switching between them when we exit. When we hit the base case, we go to a different call stack, right? That's why it's a little bit confusing. For me, it's not confusing to understand, but it's a little bit confusing to explain because it's hard to visualize all the call stacks. I will say in these types of problems, though, the best advice I can give you is the advice my AP physics teacher told me in high school, which is draw it out, right? Like, back then, with all the physics forces and stuff, I would always have a hard time in AP physics, and she would always say, just draw out your forces, right? And I will say the same thing with these recursive type problems, is just like try and even if it's in a comment, try and draw out where you are in the call stack so that you know what happens next, and so you can, or what should happen next, so you can write out your code, or at least understand code that you didn't write but you're looking at, like mine, right? So this is the reason I wrote this here, this 23, so you kind of understand how this code is going to work. So you can kind of build out our call stack, or what you should expect it to look like, by basically just printing out what answer should look like, right? So this is what I'm saying, right? We build a 1, we build it, then we recurse forward, right? So we add the 1, we go to the next index, right? We add this 2, we go to the next index, we add this 3, go to the next index. Okay, now we're out of bounds, so let's just add whatever r is, right? We do r.copy and we add that into answer, which would be 1, 2, 3, right? Then we do the pop, right? r.pop. So we're gonna pop the 3, and we're gonna have 1, 2. But then we go forward and index again, but we're out of bounds again. So we add 1, 2 to the answer array, right? Okay. So then we pop again, so we would pop the 2. But then when we move forward, we're not out of bounds yet in that particular call stack because we have this 3 to handle. So we add the 3 into R. Okay, we have 1, 3. Move forward in the index again. Now we're out of bounds. So we add the 1, 3. Okay. And then we do the same, right? When we go back, we pop the 2, we pop the 3, right? We handled those. So we only have this 1 now. And as we keep moving forward with the indexes. And then basically the same thing with the 2 and the 3, right? As you can see. And I guess, and as you can see, the empty array is the final thing that we add. This is a little bit confusing, right? Because their output is kind of sorted, but technically our call stack looks like this, right? This print statement. Okay. Theirs is different. I'm sure there's probably a few ways to do this type of problem, but this is just my solution, and the way I understand it, and the way that makes the most sense to me. So this is how I'm going to explain it. This is how I'm going to show it. Hopefully it's a little bit useful. It is a little confusing, but especially if it's your first time to introduction to backtracking. I will say backtracking is a little bit tricky. It is going to take you a while. You might have to beat your head against the wall. Completely okay, because it was like that for me. Just try and visualize what your call stack should look like at every step, right? That's all I'm going to tell you. And I just hope you listen to me, because it will make a lot of more, these types of problems make a lot more sense when you visualize your call stack and actually understand what are you doing at every step, right? Don't try and visualize it all in your head. Try and draw it out, whether it's in a comment, on a piece of paper, right? That website that I use sometimes, Xcalid Draw, right? It's like an online whiteboard website, right? Draw it out. Just draw out your call stack, and hopefully these types of problems will make more sense to you. But anyways, I hope this helped. Yeah, I'm not sure if I explained this the best. I tried. Again, it's a little bit hard to explain these problems with all the call stacks and stuff, but let me know whether this helped or not. I could remake this video, maybe. I'll think about it. It's just, I think this problem is a little bit hard to explain personally, since you have so many call stacks going on. But I hope this helped, and I'll see you in the next one. Peace out.